Decimal Division Lesson 1. There are three parts to every division problem. First part we have is the dividend. That's the number that we're dividing into pieces. The second part we have is the divisor. That's the number we are dividing by. And the third thing that we have in a division problem is the quotient. It's the answer to a division problem. You need to take a minute and write those words in your notebook for vocabulary. Remember that there are three ways to write a division problem. First, there is the number sentence way. And if you notice, we have 22 divided by 88. Just numbers right along in a sentence. The next method we have is the fraction. And remember that this fraction bar is a division symbol. This means 22 divided by 88. It also means 22/88. Every fraction is a division problem. And then we have the last method, which is the long division method, where we write our division algorithm and we put our dividend inside what I will call the house, and we put our divisor on the outside. So we have 22 divided by 88 for that one. We're going to solve some division problems now. The first division problem we have is 27 and 5/10 divided by 55. So I'm going to rewrite this using the algorithm that we know we have learned, that we're learning in class. So we rewrite our division problem so we can use our long division symbols. This is 27 and 1/2 divided by 55. What we need to do when we are doing division, long division, we need to get ourselves an index card and we cover up every number inside the house, all of our dividend numbers. And one digit at a time we are going to uncover, because division problems look very intimidating. When we uncover one at a time, we can see it's not so difficult. We first look and we say, can 55 go into 2? No, 55 is larger than 2. Can 55 go into 27? No. And I notice there's a decimal point there, so I'm going to put that decimal point right on the roof of the house right there and place my decimal point right now. And then I'm going to uncover my next digit. Can 55 go into 275? And yes, it can. It can go in 5 times. And I multiply one digit at a time. 5 times the 5 from 55. 5 times the ones digit. 5 times 5 is 25. I write the 5 down. I'll carry that 2 over the tens place, and now I multiply again. 5 times 5 is 25, plus the 2 is 27. I subtract, and I have no numbers left to divide. So my answer to 27 and 1/2 divided by 55 is 5/10 or 1/2. The next division problem I would like for you to try is 3 and 25/100 divided by 5/10. Now something interesting is going on here with this problem. I notice that I have a decimal place out here in the divisor. When I'm doing long division using this algorithm, every number in the divisor must be a whole number. So I have to multiply this 5/10 times 10 to make it be 5. When I multiply, that's just a simple moving of the decimal point from the left to the right. And I moved it one decimal place. I multiplied that by 10. If I multiply the divisor by 10, I have to multiply the dividend by 10. Now that I've multiplied it by 10, I'm going to quickly take that decimal point and place it on the roof of the house. As I look at this number, I notice that no matter what, this number out here, the divisor, that's the divisor, it is like the controller of the problem. It's the one who tells us that we need to move a decimal point. If we look back at our problem on the left, our green problem over here, we had no decimal places on the outside. 55 was a whole number already. That's why we didn't have to move the decimal point that was in the original problem. As we look at this problem here, the 3 and 25/100, this one it's being divided by 1/2, so that's why we move the decimal point. This divisor controls the decimal point. This is the controller. And it's telling us this number right here is what tells us how far we have to move that decimal point, how many times we have to multiply by 10 to get our divisor to be a whole number. Divisor must be a whole number. Must be a whole number in long division. So if it's not, we have to multiply everything by 10 until it is. All right, so let's finish our division up here. We are going to get our index card. And our index card, we're going to cover all of our numbers and uncover one at a time. Can 5 go into 3? No, it can't. So now I'm going to move my card over. Can 5 go into 32? Yes, it can. It can go 6 times. 6 times 5 is 30. So 6 times 5 is 30. I write my 30, and I'll subtract. I'm left over with 2. Can 5 go into 2? I'm going to check right here and see if this number is as small as it can be. 5 go into 2? No. So that's when I uncover the next digit and bring that straight down. Draw an arrow, bring the 5 down. Now, can 5 go into 25? Yes, it can, 5 times. And I know where to write that 5, that is directly above the 5 of the 25. I just look straight up this line and I place my 5 right up here. So in other words, 3 and 25/100ths divided by 5/10 is 6 and 5/10. I'm going to very quickly go through one last example. I'm going to divide the number 756 by 1 8/10. Again, we're looking at our controller number out here, this divisor, and we have to move it over 2 places. We have to multiply it by 10 2 different times in order to get my divisor to be a whole number. My original decimal point in my dividend was a whole number, so it is right there at the end of the number. So I need to move it over 2 decimal places as well because my divisor tells me so. Once I move my decimal place over, I'm going to place it right up on the house. Now I'm going to look at my numbers again. I need my index card. There's my index card, and I'm going to cover up all of my digits one at a time, uncover. Can 108 go into the number 7? No, 7's smaller. Can 108 go into 75? No, it cannot. But can 108 go into 756? And yes, and I need to kind of estimate about how many times that will be divisible by 756 will be divisible by 108. I'm looking, and this is about 100. 108 is about 100, and the other one's a little more than 700, so I'm going to try using 7. And I place it right over the last digit that has been uncovered. I put it right over the 6. Now I multiply 7 times 8 is 56. I write the 6 down. I carry the 5 to my tens place over here over the 0. 7 times 0 is 0, but I have to add that 5 that I had previously carried, and then now I have 7 times 1 is 7, and I subtract, and I have 0. Can 108 go into 0? No. I'm going to move this index card. I see that I have no digits left, so I need to now fill in these remaining zeros. So my answer to 756 divided by 756 divided by 108, 1 8/10, excuse me, it's equal to the whole number 700. And I just proved that with my division. Okay, I need you to write these 3 examples into your notes, bring them to class on Monday, and we will be working on decimal division in class, and have a great weekend.